Hello, I'm Jack Rickard, and we call this Electric Vehicle Television, or EVTV. I'm here with my compadre and consigliere, Mr. Brian Noto, who has come today to illuminate, elucidate, and pontificate on the merits of various magnetic electric mobility.
And thoroughly confused. But we're here, and it is Friday. And
It's
it is
Christmas Eve.
Yeah, kind of Christmas Eve Friday, I guess, huh?
Yeah.
Yeah.
So,
And in fact, this is the third anniversary of us building our original Speedster.
you know, Christmas Day was the first roll
Yeah.
of the first car. What was that, 2008?
2008. Yeah, December 2008.
That was 3 years ago, Christmas Day.
Yes.
That was our first EV Grin with
Yes.
the original Speedster.
Yep.
With net gain, Horp 9. And,
What do we have? The Kelly controller?
Kelly controller.
Kelly controller.
A bunch of Thunder Sky.
The 90s. Yeah. Yep.
We got from Elite Power Solutions.
Yes. Yep.
To my astonishment, the car not only drove, but within the first week we were driving it at 95 miles an hour on the freeway.
Yeah.
And measured a solid 100 miles on a single charge.
Yeah, we did.
And I've never gotten over it.
No, isn't that amazing? It absolutely was amazing.
I've never gotten over it.
Yeah, but we didn't know what it was going to drive, like a golf cart.
Well, I said to Brain, I said, how can a 54-year-old guy working half days, falling down drunk, build a better car than Detroit?
Then we can go out and buy it, that's right.
What's going on?
Well, something's wrong, or else something's very right.
Particularly, I'm not even a guy that likes a car. I was fascinated with the batteries. I told Brian, give me a car. I think we can make a car. I didn't even specify a car.
That's right, any damn car.
Any car, a small car.
Yeah, something, that's right.
He said like a Beetle or a Carmagia or I said, yeah, whatever. He came back with a Porsche Speedster that the engine galloped and the carburetor was all
It was a mess.
Messed up.
It was a mess. It was a scary ride down from St. Louis.
Scary ride. And we converted it to electric. I've quit watching the guys who were attacking EVs. And I've started watching the guys that are defending them.
Uh-oh.
See, you don't win the battle by adopting the same currish traits of your attackers.
That's right.
But that's what most of the EV, I'm starting to call them apologists, are doing, and it's driving me crazy. The MACNAC Center for Public Policy yesterday posted a statement claiming that each Chevy Volt is subsidized by the federal government right at $250,000 or more.
So what did they take, like the number of volts or something and divide the subsidies in it? So I guess for right now, yeah, I guess it would go down over time.
Right, but these guys are just going berserk.
Has it created a firestorm?
It, and it isn't so, and so on and so forth. And I'm reading their defense, and it's more naive than the original study, which was, you know, sort of broad.
Stretching it a little bit, yeah.
It was playing some games with the numbers, but then the response was people that aren't familiar with numbers, obviously. They toted up about $3 billion in subsidies that the federal government has given to General Motors to develop the Volt.
Okay.
But beyond that, to companies such as LG Chem, who built a battery plant in Michigan, and are supposedly bringing all these jobs and so forth. And that was a pretty big chunk. And a lot of other things that together totaled $3 billion in federal grants and subsidies directed at the Chevy Volt.
Okay.
But also the Ford Focus and some other things. And what they did was then took the 6,000 volts that it actually sold and divided them into the $3 billion and said, okay, taxpayers, so far these volts have cost you $250,000 a piece. So these guys can buy them at $40,000 so they can have a $20,000 car.
That's right.
Your tax dollars at work, and it's a very legitimate argument. Obviously, it'll change as more volts.
As more volts are in there, sure.
I think more Volts will be sold. Number one, I don't think a Volt is an electric car. But it's an interesting
It's
car.
interesting, yeah.
And I think they will. You know, again, the chant we keep chanting is that our relationship to our automobile is a very visceral thing. And we have more cultural changes to make than we do technologic.
Right.
And I'm not talking about changing the way you live and suffering for the planet. I don't believe in such.
Right. You don't need to.
I'm talking about just people becoming familiar with the cars and what they can do. I think their minds will race over the range question for the first 3 weeks they have one.
Right. And they'll wonder what happened, yeah.
And then after that, it's like, I don't really care if the car does run out of battery.
and all the cars are kind of, at that 100-mile range thing. I mean, they're kind of getting over it,
We've done it so many times, I guess I'm inured to it, but the solution, by the way, is you call the flatbed truck. Around here it's $50. I'm sure in the big city it's $150, and they back your car right into your garage for you. Give you a ride home.
Yeah, give you a ride home. That's right. You get to meet all types of interesting
burn-up
people.
motors and all kinds of broken drive shafts. I'm so
remember
used to
those
it.
drive shafts were popping out?
All the drivers know me. The tow trucks. So.
And we meet a lot of interesting people in the tow truck.
That's right.
Get out and give your local tow truck driver a call.
It's no big deal, but that we're testing and breaking cars in normal course of driving a car. I don't think about it at all anymore.
No.
I do keep track, both with an odometer and an ammeter, and I've wanted better instrumentation for a long time. I really don't now.
Yeah, I guess
it'd be nice.
It'd be nice, but there's really not that much information you need.
It just annoys me that Xantrex is so cheesy looking, but you need amp hours in your odometer, and if you know anything about your car, you don't have to be a rocket scientist. I've taught my wife to do this. She just watches, really all she watches is odometer.
Just the odometer.
Here, don't go over this many miles, and she's fine with it.
Yeah.
That's
all you need is a trip odometer or an odometer, and that's it.
So anxiety. Average annual gasoline cost per household. The Oil Price Information Service was quoted in an Associated Press article as claiming that the average household in 2011 will spend $4,155, and that represents 8.4% of the median household income. That's the highest percentage in 3 decades since the 1981 fuel crisis.
Since the fuel crisis, wow.
And so it's the last 10 years,
around.
It's averaged about 5.7% of the median household income. But it's jumped a bit. I don't know if our income's fallen or the prices.
The price of gas gone up and made people get.
That's about what you're dealing with. The average household expenditure on gasoline is $4,155. What I would say about that is it'd be unlikely that you would save more than about $4,155 by going to an electric car.
That's right. Yeah, that's right. There's no earned credit.
So for those of you who think that you're going to build an electric car and save $70,000 a year, that's not likely to happen. Tesla is the one, and we've got automotive manufacturer after automotive manufacturer getting in trouble, dropping their plan. Aptera finally had an auction selling off their office furniture.
Oh, they did? Oh, man. I didn't hear about that.
The Think has been moved to Russia. The WeGo, I see nothing of the WeGo anymore. And so one by one, the Phoenix, of course, is gone. I think the Dakota is not far away. Fisker is... I've got some more numbers. It appears that they have sold 1,000 Karmas, and that includes, when they count them as sold, is sent to one of they've got about 40 dealers. And so
the ones that are
250 of those have gone to dealers. The rest of them have kind of been sold. They're making 25 a day, and they're aiming at 60 a day, or 15,000.
That'd be 15,000, yeah.
They've raised the price of basic sedans, 106 now.
Yeah.
Anything you'd want is 116. This car, and it gets 20 miles per gallon after you run through the battery
Through the
part.
battery pack, yeah. Wow.
This car has no chance.
I can't imagine.
And incredibly,
and
they've got a whole lot of money.
Yeah, and it doesn't have that good a performance either. I mean, we've got a car that does it 0 to 60, 6.5 or 6.3.
But the other end of that is that the Tesla, my darling, and I have a deposit down on one of these, has announced their pricing, and it's right in line with what they've been claiming all along.
Okay.
They're starting touring their George Blankenship, the Apple retail guy who's gone to work for Tesla, has got his stores set up, and they're starting to tour the Model S betas in the stores.
Okay, wow.
So
that'll
you'll be
bring
able
some
to go
people in.
see one at a local Tesla store near you.
Yeah, wow.
The pricing for their base model, this is a 160-mile range vehicle with a 40-kilowatt battery pack.
That's not bad.
And no leather.
Okay, all right, okay.
Is $57,400.
That's
now,
not
this
bad.
is not a good value proposition again. It's a very high price for a sedan, but it's a modern all-aluminum sedan. It has seating for 7 because they've done some remarkable things in the space.
The way they
You've
designed
got quite a computer system on board, 19-inch screen. And I think it'll be very appealing to early adopters.
I do too.
It's not going to be a bargain value car, but if you've got the Ducats, it'll be the thing to have, I believe.
But if it performs like a BMW or Mercedes or a Lexus or something, they're right in line with their mid-sized car.
The thing is, you're not going to be able to get one.
No, huh?
This is very, but it's cunning the way they do that. Then they have a 60-kilowatt battery pack, 230-mile version. That's $67,400. And finally, and that'll do 230 miles for $77,400. And I priced this car. I said this car would be $77,000.
And that's
from the beginning.
That's
when they
from the
were
top
talking,
of the line one.
When they were talking 55, I said, you watch, anything you'd want in this car would be $77,000. I named the price, and I nailed it. I missed by $400.
$400. That's within.
That's pretty
that's
close.
Statistically
I knew what this car was, and there was they didn't talk about it at that time. I made up this number completely, $77,000. They're at $77,400. That gets you an 85 kilowatt battery pack, kilowatt hour battery pack.
Okay.
And a 300-mile range. But only Dan Friedrichsen can flip out on this. But when I say kilowatt, we're talking about kilowatt hours. It's a storage function, a capacity measure. And I keep slipping and saying kilowatt, abbreviation. But it's kilowatt hours, as I assume all of our viewers know this, except for Dan Friedrichsen. A 300-mile range for $77,400. And so, now here's why I said you couldn't get it. The first ones in the summer, or could be the summer of 2012, is this 77.
Is the big
well,
boy.
actually, the first ones, they have the first 1,000 are their signature version. That's for guys who paid $40,000 deposit.
Oh, okay. That did a premium on the deposit line. Okay.
And then after that, it'll be the they also have a performance model, same battery size, but $87,400 with a little bit bigger motor and some other niceties. It gives it a 4.4 second 0 to 60.
Wow.
So I think you're going to see that performance model and the $77,400 85 kilowatt hour Model S will be available first.
Become the first one.
Kind of the summer, first couple of months, middle of the summer.
Okay, that's not bad.
As they get those worked off, then in the fall they're going to introduce the 60 kilowatt 230 mile. And by the end of the year they'll have the 160 mile version 40 kilowatt hour.
Okay.
Now, give me a break here. $57,000, $67,000, $77,000. All three are too much for a car.
Right. Yeah.
You got to want a Tesla.
You got to want a Tesla. Yeah. And who wants the weenie one?
Who wants the weenie one?
Right.
If you can afford a Tesla,
yeah. Who wants
why
the
would
weenie
you
one?
want the 40 kilowatt hour car?
Yeah.
And it's not that you need it, by the way. That 160 miles
range
is enough to lap yourself weekly.
Yeah, yeah.
On the same charge.
Yeah.
But nobody's going to want that because of the bragging rights.
Yeah,
right now, it's a range-driven game. It'll be 4 or 5 years from now before it'll dawn on people, hey, I'm paying too much for too much battery here.
Right, I got too much battery pack, yeah.
Because I'm just carrying around a bunch of weight and I never get to 300 miles.
Yeah, right.
You know?
Right. Yeah, I know. I wouldn't drive the Tesla if I went that far.
But because of the novelty and so forth, it's going to be an issue.
Right.
And so I doubt they will. I want to predict that they will never sell a legitimate sale of a 160-mile version, the 40-kilowatt car. They'll have to arrange something internally to claim that they have even sold that.
Give a couple away on a radio station.
Under the homologation rules.
That's right.
For automotive racing.
Give a couple away on NPR and Palo Alto.
Yeah, right. To get on NPR and Palo Alto. They'll sell it to somebody's brother.
They'll sell somebody's brother, yeah.
But there will never be a legitimate sale of a 160-mile range.
It doesn't make
Tesla.
a lot of sense. Not when you're talking over 60 grand, yeah.
And so it's going to be, as I said all along, $77,000. I mean, you know, the 67 for the other one. You might, I mean, a case could be made, drop to the 60 kilowatt and load up on the other options. So be at 77.
Yeah, so a couple hundred miles. Yeah.
And the other options are all pretty reasonable. You don't have to like have an option to get a charge port or something. You know, I mean, it's all
there.
Yeah, it's all there.
Yeah.
But there's some things
Nice.
you can get, a different size tires. They've got some aerodynamic wheels that will extend the range a little bit.
Okay.
Leather, you know, interior, that sort of thing. But I'm very excited about it. I was unable to make it out for their party.
Oh, when they had the
when I wanted to
the
go,
opening,
but
yeah.
That's so the Tesla Model S is the only thing on target. Well, battery companies, let's talk about them. Saft has, in September, opened their new $200 million lithium-ion battery factory and moved their American corporate headquarters there in Jacksonville, Florida in September.
Oh, really? Wow.
235,000 square foot plant. They had a $95.5 million federal grant from the Department of Energy. And had incentives from the state of Florida and the city of Jacksonville. They expect 300 million annual sales on these batteries. So that's kind of, it's becoming apparent, at least to me, that, and we may already be looking at this, that there is an oversupply of batteries. Eventually, the oddity is we may wind up with falling prices and unable to get any at the same time.
God.
But there's a lot of strange things. Balcon, we had talked last week about them and their strange behavior toward us. Apparently not so strange after all.
Really? Okay.
I went and pulled their 10Q. Balcon's a publicly traded company. They have to file certain documents with the Securities and Exchange Commission, and they don't really get to have secrets when they're publicly traded stock.
Right.
There's not much you can keep secret.
No. No.
Including their deal with Winston Battery Company.
Oh, really? That was in there?
Oh, yeah. And Winston gave them $2.2 million worth of cells.
No, okay.
In the past year, they have sold about $435,000 worth, and their cost on that was like $375. It wound up being 85 cents on the dollar.
Oh,
so for every dollar you spend on batteries, they're spending 85 cents. They're not making a lot.
Not making a lot, no.
This is a little company who's been on death's door before Winston showed up. They make actually a truck for cargo containers.
Yeah, and they're right there if they're in Harbor City or Long Beach. Yeah,
Right.
the two big
And they
harbors.
sold the bunch to the city of Los Angeles.
Okay, for the port.
And they don't work.
Uh-oh.
They can't make it through the day. And they're facing a refund on that and some legal difficulties.
Man, that could be tough.
Their main prospect is a $15.9 million contract for their drivetrains. They've done I think they're using a Siemens motor, but they've done their own three-phase controller. And it's a pretty big rig for these trucks. And they have sold a bunch of them to Winston Chung again to put in buses and RVs.
Oh, the RVs. Yeah, that's right. Yeah.
And they're priced at like $53,000 a piece for these drivetrains, which I think is an extraordinary amount of money for a drivetrain and a vehicle. But Chung has bought $15.9 million worth of these, and they're ramping up to make them. And I think Winston Chung is kind of gotten to be a little bit erratic over this situation with Thunder Sky and Sinopoly.
And they're kind of bumping heads, huh?
Well, here's what happened. They didn't name them by name, but they did note in their 10Q that they had received a letter threatening legal action on the sale of the Thunder Sky Winston Battery Company batteries based on patent infringement. Now get this. This is so cool. We are in a neat space because it's just so wow.
It's so crazy right now.
It is so crazy. Nobody making anything in the United States of America wants to make it here. They want to make it in China. What's their biggest problem?
That did get knocked off.
Yeah, that's right. If they make it, it's in China to get made, the Chinese knock it off and sell it against them, and there's no way to enforce patents.
No.
Guess what? Sinopoly, Thunder Sky, used to be Thunder Sky, that Winston Chung started, is suing Winston Chung over patent infringement of the batteries. And the only place they can really make this stick is here in the United States.
Oh, Jesus Christ. So they're just...
So we can't get enforcement of our patent laws in China. But China can get enforcement of our patent laws in the U.S.
United States. That's wacky.
And so we have a Chinese company going after an American company that's the front for a Chinese company here in the U.S.
Oh, man.
Over battery sales. And this little Balcon, their annual sales is like $4 million.
Yeah, it's not a very big company.
I doubt they have a lawyer on staff.
Yeah, probably not, yeah.
They got to pay the hourly rate to get a lawyer.
Oh,
and they want nothing to do with this fight, certainly not for 15 cents on the dollar.
No.
And Chung has saddled them with being the United States representative and sole and exclusive source for these batteries, and they're scared to death to sell any of them for fear of being sued by Sinopoly. And it isn't how the suit comes out they're interested in. They don't want to buy a lawyer to even show up for this.
Right, they don't want to just pay the money. I don't blame them. God. Isn't that crazy?
Winston Battery Company is effectively out of business in the United States. And Sinopoly, I cannot find evidence. I have combed the land, asked people publicly. I do not locate a U.S. sale.
No, I can't either when I've tried.
Of a Sinopoly battery.
No, some overseas in Europe and things, but here, nothing.
Oh, meanwhile, do you remember 2 years ago, 2.5 years ago, Thunder Sky doing a deal with the Soviets, Russia, to build a plant there?
A plant.
That's now the largest lithium battery plant in the world.
Yeah, that's right. They did that thing with the Russians.
It's enormous.
Yeah, that's right.
And it's up and running already.
It opened a few months.
In 2 years,
it opened a few months ago, didn't it?
Prairie grass to battery plant, and they are now producing lithium-ion cells. Thunder Sky lithium-ion cells.
Isn't that amazing?
But Thunder Sky isn't. Thunder Sky is no more. It's Sinopoly's Thunder Sky. Winston Chung was Thunder Sky. And it's all balled up in a mess.
That's right. You need a dance card to keep all the partners straight here.
Meanwhile, we've got a project using their batteries, their money, their batteries. We're running an ad for them, and you can't order the cells, as best I can tell.
I know.
Help! Help!
Jeez, it's curious.
I feel like the scarecrow in the poppy field in Oz. Help!
Puppies, puppies.
Puppies.
We've definitely gone down the rabbit hole. We have gone down the rabbit hole.
Yes, we are. Toto, I don't think we're in Kansas anymore.
No, we're not. Must be in China.
Meanwhile, Jim Delgado has sent me a shipment of Headway's.
Oh, yeah, we got the Headway's, yeah.
HP cells. These are gorgeous little batteries. And I bought you a bicycle today.
Oh, you did?
Actually not. We've got a bicycle laying around here somewhere, but I got you a wheel, motor, and a controller and everything, and we're going to make a little pack for the bicycle out of the Headways.
Okay.
Just to see how it does and maybe make them useful. He just sent us some sample cells.
Oh, cool.
A few of them. We're going to test them, some of them to death and destruction.
Sure.
But we should have enough to put together some sort of little bicycle pack, I would think.
Okay.
And it fascinates me that 25 million of these bicycles are going into the hopper every year in China.
Isn't that amazing?
It is
That's
just
amazing.
a stunning number.
Yeah, that absolutely
and
amazing.
so we never talk about electric bicycles here, but
No.
And I don't think it's really a solution for American mobility, but it might be fun for a few people.
Yeah, absolutely.
Tell me about your swallow. What did we do this week?
Let me think of what we have done this week. Well, we started.
You got seats.
Yeah, we got some seats. We got carryover at Special Edition. Sent us over some seats. Same ones we have in the Speedster and the Spider. We're going to try to make those
kind of thin little buckets.
Yeah,
we're going to try to rig that up somehow where I could actually sit in this car on purpose.
Yeah, we're going to see if we can get this thing to where it's where you can get in and out of the car. You know, we've got to get the seats up high enough and back far enough where you can see out over the hood, and also to where you're not cramped up with the pedals. Remember, we've never driven this car. I don't even know what the pedal position really was like.
I don't either.
So we're going to have to.
You moved the. This is you're calling it a roll bar, but this is where we're going to tie the seat belts.
This is an attachment point for our 2-inch harnesses.
We've added my honeycomb.
Yep.
We have a number of viewers who are very concerned that this amount of heat sink isn't going to be adequate for the controller. I assure you, you're wrong. It will be plenty.
This is a lot of
heat
sink.
We don't need the honeycomb, airflow through the honeycomb or anything like that. What I need is a large surface area of just a thin piece of aluminum to wick some of the heat away from the controller and to the air. And this will work admirably. Rod has painted it already, so you can't hardly see it.
Yep, it disappeared.
We have a saying, you paint it black and it'll disappear. This has pretty much disappeared.
Yeah, you can't read that on my T-shirt.
Lee Moorhead has declined my offer of our fairly expensive charger that would have undercharged his cells a little bit and made them last about 1 million years.
I know 1 million year cells.
And the 2-hour charge time, and so we got him a little 2,500 here.
Yeah. We just put that on today.
Do a good job. It'll charge to 133 volts, and that will fall after charging to 126 maybe, or 125 volts, and that should still be in the range of this controller. I'm told 130 volts is where it winks out. Now, sometimes if it's too high, you have to turn on some headlights or something, bleed off a couple of surface charge.
Yeah,
and
but that's quick.
And that is the 650 amp.
This one here, yep, this is it here.
And so I think it's overkill for this thing, but we've got this mounted very nicely here. And
this is mounted
it'll
now.
be on the heat sink and blowing up, and that's
Contactors in, yep.
This is our connection, a little Anderson connector. We'll run a cable and connect right here. You've got a contactor. This controller requires a what is it? An AN5AN Tyco kilowatt contactor, a 24 volt coil, and that is quite important. I have tried to beat this several ways, like using two contactors, two 12 volts, ought to be the same impedance as a 24.
Yeah.
No,
it didn't work.
Another type of contactor.
Yeah, another 24 volt didn't work either.
And that didn't work. You have to have this
this one here,
little ANA 5AN Tyco kilowatt 24 volt coil, or it won't work. Actually, you've got a direct copper strap to the positive input,
and this to the positive input. Yep.
We'll hook our charger up to the other side.
The charger can go here.
Side of the contactor, and the other connection to the negative terminal.
Yep, right here on the controller.
And that'll go straight up to our battery pack. I'm probably going to leave this little 3-prong, take a little 3-prong female, and we will mount that J1772 on the body.
And that'll give us a disconnect.
Unplug it to lift the body off. Again, we're trying, and we're kind of failing, Lee, in putting in the seats. I don't know that we're going to get there. I've been trying to rig this up where you could lift the body off if you wanted. Just disconnect a couple of plugs. And I can throw in some plugs and do a little wiring where that can happen wiring-wise, but I don't know about the seats.
With seats and the steering.
Seats, and the steering too.
Steering is mounted to the body.
Yeah, but you can make it where that steering disconnects pretty easy, can't you?
It's up front. It's not bad. It only really it slides into that one coupler on the steering box.
So it's not a matter of loosening the coupler and lifting.
And then pulling the steering. You have to loosen.
We might get there. I think the seats is what's going to get us.
Yeah, we'll try a couple different things.
He's going to try to put it on some rails on the front part here that would slide back over the body, and you just move the seats forward and pull the body.
Yeah, we're going to give that. I don't know. Yeah, we're going to give it a shot and see if we can do it.
We'll see how that goes. But it's coming together. It's kind of been slow. We've got a lot of other things going on, but I think it's coming along very nice. This is going to be a deluxe little vehicle.
Yeah, very nice. I like it.
So it looks good. And show me what you did on the Escalade.
Okay, let's take a look.
NetGain Motors, home of the Warp, Transwarp, and Impulse motors, introduced the improved Warp 9 motor. The Warp 9 is a 9 1/4 diameter series wound DC motor with a double-ended shaft featuring 26 improvements for 2010. Externally, the terminal studs have been enlarged from 3/8 to 1/2 inch diameter. Bigger is better. On the inside, a larger commutator, new brush composition, and split brush design with heavier springs handle even higher voltages and currents than before. Our new fan increases airflow by almost 50% over typical paddle-style fans, and all this translates into improved performance. For even more performance or larger applications, take a look at NetGain's Warp 11 motor, an 11 3/4 diameter series wound DC motor for even greater torque and power. Since 2002, NetGain Motors has been leading the EV industry with precision, performance, and price. Visit us at go-ev.com. NetGain Motors, warp power to go.
Brain, I didn't think I'd see this, but we got a problem. Our truck is squatted down on its tires a little bit.
The same thing that the Mini Cooper did. Yeah, we got a little, and we dropped about the same, about 3 inches.
Yeah.
2.5, 3 inches.
It's squatted down now. You know, we've still got the engine in up there, but we put those 2 motors and some other stuff up there. It may balance out, but right now, I mean, we're not rubbing or anything, but it's sure going uphill.
Yeah, we're starting to low ride a little bit.
Brian finished off populating our battery box with the straps and so forth, and cabled it up to our terminals. And this is the biggest battery pack I've ever seen. It's 76 kilowatt hours, Dan.
Yeah,
It's
76 kilowatt hours.
duh. Got this little retard in Denmark that keeps sending me email.
Kilowatt hours, not kilowatts.
Yes, it's not kilowatt, it's kilowatt hours. We all know this, Dan. All our viewers but you. But I did say kilowatt, it's kilowatt hours. But we've got quite a pack there.
We've got 3 rows and 19, I guess, for 57 cells.
Yeah, 1,650 pounds of cells with those straps and bolts and that box. Probably 1,700 pounds.
Yeah,
those
those bolts are heavy. Yeah.
That turns out to be a little bit much for the Escalade.
It started sagging, and I turned the car on, and I'm not getting that self-leveling. So I don't know if it's at some point it doesn't work, or if what we already disconnected maybe has stopped it, prevented it from working.
We're going to have to find out more about the self-leveling thing.
Yeah.
And I'd love to just be able to bolt on some stiffer coilovers.
Yeah, we may have to get our guys in St.
Mary's.
Mary's.
In St. Mary, Kansas. Who was that did
Coil Spring Specialties.
Yeah, Coil Spring Specialties.
Yeah, they did the great job for the Mini Cooper. Yeah,
yeah.
Nice job.
Well, I'm not above doing it again, but you can't just do that with that.
With that self-leveling.
Self-leveling thing.
Yeah. So yeah, we may have to do that with the springs.
Getting through the bed, so you're hooked up to the 2 terminals.
We're at the
we
2
want to
terminals.
drop right down through the vehicle underneath.
Right, exactly, and that's what we've devised here with these gland nuts. Yeah, I can see land ho.
Mm-hmm. Yep. So this is just a piece of PVC pipe. We have it with a wire brush to make it thinner, so it fits right inside our thing. This one's glued on.
That one's already glued on.
You put a little PVC
just
dope.
regular PVC glue. Yeah, yeah.
And then our gland nut is on there. Of course, it can be tightened down around the cable pretty smartly.
That 4-aught cable
to make a weather-tight seal. But we have to drop that through the truck bed, stick this on from underneath, and put a little glue on it first, and we'll put that on, and that will go right through the bed. Several layers of metal.
Yeah, it was not as bad as I thought. It was only about 2.5 inches. It looked like, but it was a cavity that we had to negotiate there, and that's our solution. Is the gland nuts and that chase. Yeah,
and that will let our 4-aught cable go right through there, and it will not chafe then.
No,
it'll be rubber. In case these are strain relief grips,
yes, strain relief
or
grips.
gland nuts is what you call these. And we get these from, this is a PG 36 size, a big one. But we get these from a company called Electrek.
Electrek is where those came from, yep. Yeah.
And these are the strangest people I've ever done business with on the internet.
Really?
They have never gotten an order right the first time, ever.
It's part of their charm.
And I'm pretty sure there's some significant drug use going on.
All right. Well, then we like them. What the heck? They're okay by us.
But then they do kind of everything to try to make it up, and they keep sending me free LED flashlights and stuff. They're just a strange group of people. But they have a very eclectic collection of odd connectors and
really?
Terminals and
cool. Just the oddball stuff that
switches you don't see everywhere.
Until you see it, you go, "Damn, I didn't know I needed one of those."
I didn't know I needed one of those.
Those are cool. That's right.
And a whole bunch of different sizes of this. But for example, they carry the pins and the connectors that are the same connectors that are used on the Brusa charger.
Oh yeah, remember what a problem we used to have with that? Oh man. Oh, that's cool. They have them.
Yes, they have them, and I've got them. And I've got a Brusa I intend to repair at some point in the future.
Land ho, ahoy, maybe.
Ho. So that's our strain relief. We've got our pack up.
Packs in.
We'll, I guess, start wiring up our heater.
Yeah.
We don't even need the engine pulled for that. And our DC to DC converter, and that'll give us 12 volts. And we can have quite a bit of that. Now, why did I put the batteries in the bed when I had all that space underneath?
Well,
Actually, we'll use a lot of that
We're gonna
space for
use-
heaters, DC to DC converters and stuff,
Yeah.
and keep it out of the engine compartment, and that'll
Yeah.
look very nice up there.
Yeah, and this is a really, the impact of this size battery pack is pretty cool. And we like to show this stuff off. I mean,
You know,
people like it.
Brian keeps saying people like to look at the batteries. I've got an aluminum top for this box.
Yeah, we do have a
It's already
nice top.
drilled and tapped.
I know.
We'll just use it for something else.
Yeah, we've got
we're
a
going to
nice-
get some polycarbonate and put over there because people do like to,
They like to see the battery. They like to see the batteries.
And this is a pretty good bragging right here on the side.
This is impressive. This is a big
battery pack.
Yeah, this is a big battery pack.
So we'll maybe do some decals or something, some sort of label with how many volts and how many amp hours and
Yeah.
so forth.
Winston batteries.
Winston batteries. Yes, we have a Winston.
Maybe we'll get sued.
I know Polly's.
They'd sue
We're
us.
advertising Winston battery. You can't buy the Winston batteries.
and we don't, I don't think
Valcon
Sinopoly's selling
can't
them.
sell them.
You can't get a Sinopoly.
And Sinopoly doesn't. I don't know, but we're going to have a big vehicle with a massive pack of very, I think, pretty excellent Winston 400 amp
400
hour
amp
cells.
hour cells, yeah.
And there you go. And there you have it, and that's that.
Yep.
NetGain Controls introduces the new Warp Drive Industrial Controller. The Industrial is designed to handle a maximum of 1400 amps and up to a 360 volt nominal battery pack. The unit's rugged design looks and works great in the automotive environment while protecting it from the elements. In addition to higher continuous currents than the classic Warp Drive controller, the Industrial comes with several major enhancements. Liquid cooling is available and uses leak-free and rugged AN fittings. The Industrial controller has complete isolation on both throttle channels, giving the highest possible immunity from situations that might affect the electrical throttle input. High voltage connections are fully protected underneath the sealed cover. Voltage leaks between vehicle chassis and a battery pack are detected, alerting the user to potential safety problems. Controller settings can be completely customized using the NetGain Controls interface module, which can also log data to an onboard SD card. The controller weighs in at 25 pounds. Visit www.ngcontrols.com to order your Warp Drive Industrial Controller now.
I thought we'd do a little segment on EVSE. We're back here in the garage where EVTV started, and I've got this Ford Edge conversion that we inherited from Arnold Flarsgaard. We've done quite a bit of work on this. Haven't done a big thing on the show. I hated this car at first. Gradually, I'm getting where I kind of like it. The problem is it's an automatic transmission and it shifts horribly, and it had the batteries in here horrible. But we've been playing with it. Brian just added a J1772 plug. This electric car, and of course the broom I'm using to sweep out the garage represent my wife's two main modes of transportation, the car and the broom. But plugging it in the way we had it set up was kind of tedious for her, and it sparked a couple of times and she didn't like that, and so we've added the J1772 plug. Here in the garage, if you recall, we've talked about EVSE all along, electric vehicle support equipment. This is not a charger. Some people are calling them charge stations. I think that even confuses the issue. The proper term is electric vehicle support equipment, or EVSE. This is a General Electric watt station. And the reason I bring this up was I was able to purchase this at Amazon.com, one-click ordering for about $1,000. If you recall, most of the EVSE was coming in at $3,000 to $5,000, and I said that was a little too much, and showed you how to build one yourself for between $800 and $900. Now, the notable thing about that is when you got done, it really was between $800 and $900. There's no $200 way of doing this, and it actually operating as a fully functional J1772 charge station. $1,000 is pretty close. Now, the one I showed you how to build had a beautiful cord and connector and very heavy contactors and a nice metal enclosure. But this is pretty snazzy looking. It's lit at GE. It hangs on the wall. We've just got it plugged into a 220 connector right there. It'll do up to 40 amps. However, you do kind of pay for what you get. I think this is probably the cheesiest little pistol grip connector I've seen in the J1772 space. So GE has found a way to save some money. Even the contacts do not look as heavy duty. But the purpose here is to have this kind of connector so my wife can plug in the car with a little more assurance. What we found over time was our ways of doing it with various NEMA connectors all worked. And they work pretty well. The problem is you plug it in every day and you unplug it every day. And that puts a lot of wear on those things. These J1772 connectors are supposed to be engineered for 50,000 insertions per unit. And so it's a little heavier construction. This one barely, but it makes it easier. And what we found over time is if you live with an electric car every day, you wear out your little connector. I don't care which of the NEMAs you use, it still wears them out. This is simply a more solid connection, and it is safer and less arcing and sparking. And so I can take this. Here's the other end of the GE watt station. What would you say that is? 12 feet? 10 feet? 12 feet? That's kind of a short cord. You have to consider where, and there we come on, and we're on and running. You have to consider where you're going to have your car parked and where you're going to have your wall station, because you don't have much cord to play with here for $1,000. We normally put an 8-meter cord on that's essentially 24 feet. This is probably half of that. And so we've got to be parked in the bay next to the wall, and we pretty much have to be head end to be able to reach here. That said, once you have that set up, it's set up. On the car, we did install a connector. I didn't want to chase down 12 volts and all of that, so we came up with a quick and dirty way of getting this to energize, and I mean the quickest and dirtiest you can do. And that's a 750 ohm 5-watt resistor and an ordinary 1N4001 diode. And we connect that with the positive end of the diode connected to our co-pilot signal, the red wire off of our connector, and the negative end of the resistor to the neutral connection of the thing. And so as soon as you plug this in, it instantly starts energizing. Now that works out fine with a GE watt station because it has a procedure it goes through anyway to bring it up. And so if I disconnect this, just pulling it out completely removes power from the cord. And if I put it in, it goes through a little procedure about 3-4 seconds and then comes on. And so that's plenty of safety in the process, and we've got a good safe way to connect and disconnect, and one that will last over a period of time. Using a resistor and a diode, the connector here, and our $1,000 GE watt station, it let me throw together a quick and dirty way for her to charge without wrestling getting the plug to seat that we had a big NEMA 5-15 that would plug in here. But it was just scary, and occasionally it would arc and pop, and it was already wearing down after being in the car not 2 months. And so this will be a little more durable, a little safer, and a little more approachable for her to charge the car. She does like not going to the gas station, and I didn't know exactly what that meant. It wasn't the expense. She didn't like going to the gas station and was somewhat jealous that I never went to the gas station and got gasoline all over my hands and had all the guys gawking me at it being 20 degrees out. And so they still don't gawk me, but now she doesn't have to go either. So that's the GE Watt station. I think it was $1,050 at Amazon.com. Home Depot now carries 4 different charge stations. I think this one's just slightly under $1,000 with them. So the EVSE, as I predicted, has quickly collapsed in price, and the $3,000 and $5,000 home units simply have disappeared. Again, the early adopter pays, and now we're starting to install these, and General Electric's gotten into it. General Electric feels that of every dollar spent on electric cars, they're going to get 10 cents of it. I would bet that's probably about right. They tend to get involved in everything electric, pretty much since absorbing Edison. So that's our J1772, SAE J1772 2010 charging connector for the Ford Edge and the GE Watt station. This episode of EVTV is brought to you by the Winston Battery Company Limited, makers of high-capacity lithium-yttrium rare earth cells, including the popular 160 amp hour model featuring cycle lives in excess of 5,000 cycles when discharged to 70%, the longest useful working life of any available battery of any chemistry. A leading battery technology scientist, inventor, and entrepreneur since 1995, Mr. Winston Chung envisions a new world of clean electric power for the dawn of a new era of electric vehicles. For your next electric vehicle design project, contact Winston Battery Limited. Energy for a bright future.
Hello Jack and Brian, this is John Allen from New York. I've spent the week cleaning out the front end of the car, all the components that were there, putting them away neatly so that I can find them the next time. And I'm basically doing it all over again in this car, taking it down to the bare bones, and it's not going to just take a week or so. It's actually, there's a lot more to it. I'm putting new components in, and I hope at the end of this I can say that I've done 2 EVs. However, I'll only have one to show for it. That doesn't really matter, but it would be nice to have 2 to show for the amount of work I'm putting into it. Let's take a look. I've removed most of the stuff out of the engine compartment, or the motor compartment. As you can see, I've been getting all the wiring out, trying to make heads or tails of everything that I've got there, or that I had in there. I'm trying to keep it well sorted so that when it comes to putting it all back, I know where I am. I'm just about to remove this power steering pump which has been underneath the battery rack over here. I'm also removing the whole cooling system. There's the reservoir. So I'm just trying to get it to a point where I can lift out the motor and the transmission so that I can make all the changes that I'm making to that, putting the clutch back in, etc. So in order to remove the transaxles, I'm going to refresh my memory using the Haynes repair manual, and kind of gives you a guide, picture guide on how to do stuff. It's quite helpful. For someone that doesn't do this, on a regular basis, it's quite important to have something like this that looks over your shoulder a little bit and tells you what to undo in order to get the job done. And also it tells you which tools you have to go and buy in order to do it. There's a few specialty tools, like removing the wheel nut has a special tool that you have to get, and stuff like that. It's quite important to get a little idea of what you're doing if you've never done this before. So there I'm draining the oil out of the gearbox so that I can then remove the transaxle up here, pull that out of there, and then one on the other side. So in order to remove the transaxle, I have to get this cotter pin out here and then remove this nut cover, and then I can undo that wheel nut, which will allow me to disassemble this off the end of that transaxle. That's my next thing that I have to get done. So I'm going to remove that pin, get this off, and undo that nut. Okay, there's that cover off. Now I can get my special tool onto this nut to remove that. This will work. Yeah, that's good. Oh yeah, easy. Beautiful. It helps to have something like this. Really huge piece of pipe, which I open up. It's got the wheel nut off. Don't need the cover bar anymore, except the other side. So I have the drive axle disconnected now from the wheel, and all I have to do now is pull it out of the transmission. My next thing to do. And also remove the one on the other side as well. So I'm going to go ahead and undo the other side next, I think. Santa arrived disguised as a FedEx delivery man and brought something for the EV, so I thought we'd open it up and take a look. Let's take a look. So this is from Brian at Fast Brakes. I ordered them some time ago, but apparently the research and development took some time. And he had some delay with getting parts, bits and pieces. Which, anyway, eventually they arrived. And here they are. So this is really neat. It's pretty exciting. Take a look over here. Oh, this is beautiful. This is a pretty lightweight caliper. Oh, very nice. That's very nice indeed. Yep, that's a Willwood caliper. So that's nice. So that must be the second one. What do we have here? We'll look at that in a minute, but let's take a look at this. Ah, yes! New rotor. Very nice. Okay, that's quite a bit. There we are, the nice two rotors. So they've increased in size, in diameter, because I was having a little worry with that extra weight that I had. Oh, these are the pads. Very nice. Oh. Okay. Brackets. So that's nicely put together. There's some instructions in here how to put it all together. There's the other caliper. Very nice. Very nice indeed. some hoses here between different shipments. Those are very pretty. Always very exciting. So I've just done a loose fitting of the new discs here, the new rotors, with the Willwood calipers. I just wanted to see if this is actually going to fit. And I'm going to just get the tyre now, the wheel, and put that on and just see if it's all going to work, that this doesn't interfere with the rims, etc. So I'm just going to have a quick look at that. Just want to clear it, you know, they just got delivered by Santa, and I just want to make sure that they all work, so that I don't have, you know, to wait in case they don't fit when I get to putting the car back on the road. Looks good. It's good clearance from the calipers to the wheel rim. There's a bit of clearance all the way around. So that was the week. It was exciting getting the new brakes, and it's great getting further and deeper into the vehicle, getting it all cleared out, so basically starting all over again. And that's all I have for you this week. So that's me, John Allen, from New York for EVTV. Have another great week.
Hello, my name is John Hardy. I live in England, right in the middle of the country, just south of Birmingham. I'd like to share with you, if I might, something I've been working on, which I think might be of fairly wide applicability, and it relates to battery fires. Battery fires have been very widely reported, and Jack has very selflessly demonstrated on a couple of occasions what happens when you overcharge a battery. And the typical scenario seems to be that charging doesn't terminate when it's supposed to, and the battery overheats and catches fire, and this seems to be happening in the middle of the night in rather awkward circumstances. And the fundamental problem seems to be that there's really just a single point of failure. The charging system has to terminate charging correctly, otherwise there's a problem. And if you install a BMS as well, then you've got two bits of electronic equipment which both have to work right to be sure of getting a safe charge termination. So what I've done is I've put together a sort of proof of concept rig to show an approach which I hope might actually help prevent some of these fires. This is the material that I've been using. It's linear heat detection cable, or LHDC. This is actually the digital variety, which is one-shot material. It's not resettable. There is an analog variant that's resettable but requires more complex controls. This in essence is much like the sort of wire you would use for wiring up equipment in the house. It's got two cores, each insulated within an outer sheath. The main difference, however, is that the two inner cores are insulated with a material that breaks down at a specific temperature. So if you get an overheat condition anywhere down the length of the cable, the two cores are shorted out, and if you can detect that and use that to shut off charging, you have yourself a defense against overheating anywhere along the cable. Before we look at the proof of concept rig itself, it might be useful just to look at a quick schematic of what's going on. Obviously the core of it is the length of the LHDC, the linear heat detecting cable. One end is connected to a 12 volt supply and the other end to a relay, so that under normal conditions the relay closes and the power is supplied to the mains output. Unfortunately, as it stands, that's a little bit of a bomb, because if the LHDC shorts out, you then have a dead short across the 12 volt supply, So I've actually added a small pilot lamp which prevents that from happening, and also has another benefit, as we shall see. This arrangement is somewhat self-testing. If you get a break in any of the wiring, or a break in one of the conductors in the LHDC, then the power doesn't go to the relay, and the charging equipment will remain off. If you get localized heating in the cable, then, as I've already described, the insulation between the two conductors breaks down and you get a short circuit in the cable. That has two effects. Firstly, the light will come on. With the normal power supply to the relay, there just isn't enough current to light the lamp, but with the short circuit in the cable, you get the full 12 volts across the lamp, so it'll come on. And secondly, of course, the power to the relay is interrupted, so the charging equipment will shut down. So that's the principle. Let's have a look and see what it looks like when it's laid out on the bench. This is a general view of the proof of concept setup. We've got 12 volts coming in here, the LHDC cable there, connecting wire coming around to this relay, and then mains coming in here going through the other half of the relay and out to this lamp, which represents the charging equipment in this simulation. Moving in a bit closer, this is the pilot lamp, which is wired just as it was shown in the diagram. This is the relay. The coil input are the two wires furthest from the camera, the green and the blue, and then the power out are at the bottom, the brown and the other blue one. You probably wouldn't use this particular type of relay in a live situation. It costs a grand sum of £2. It has a 12 volt coil and can switch up to several hundred volts. And if I short out the coil of the relay, you'll see what the effect is. Essentially, the power to the mains goes out and the little pilot lamp lights up. If I take this hot air gun and apply it to the cable, you'll see what happens. And that's the demonstration of the LHDC cable in action. So how might something like this be used? Well, here's Jack's diagram for J1772 wiring. The EVSE on the left, the supply equipment on the left, and the wiring in the car on the right. And you may remember the principle is that when the car is first connected, the switch is open, and with just a single resistor in the circuit here, you have about 9 volts at the terminal, which indicates the EVSE that the car is connected but it isn't ready to accept any charge. Then when you're ready to accept charge, you close the switch, and that drops the voltage here to 6 volts, which says to the EVSE, I'm here and I'm ready to accept a charge. So one approach then would be to replace that switch with a relay, and then connect the relay up to a 12 volt source through some lengths of LHDC in the battery boxes. And that way, under normal circumstances, you'd close the switch in exactly the same way as you did before, and power would flow to the relay, and put R3 into the circuit, which would drop the voltage to 6 volts. But if you got an over temperature in any of the battery boxes anywhere along the lengths of LHTC, then the circuit would open, and just as we saw on the bench, that would cut the power to the relay, which would put the pin voltage back to 9 volts, which would say to the EVSE, I'm still here, but please stop supplying me with any power. This would be another possible layout. It's just a variant on the one we were looking at before. Here I've assumed that your particular concern is the terminal temperature, and I could see counter boring the attach bolts for the hardware, putting something like an M3 tapped hole into the head of the bolt, and then using a small brass P-clip to hold down the LHTC, and that way you could actually keep pretty close tabs on the temperature of the connectors. So where did I get this stuff? The LHTC was supplied by a company called Patol, and there's the web address, www.patol.co.uk. I've no connection with Patol, but they've been extremely helpful so far, with not the slightest sign of sort of fixation with OEMs. They claim to have customers all over the place, so supply to Western Europe or Eastern Europe and the US should be no problem at all. They tell me that their digital and analog cable is, well, it's between 2 and 3 pounds a meter, with the digital being slightly cheaper than the analog. Typical controllers are in the range of sort of 275 to 475. The controllers apparently are already, I asked about this specifically, they're hardened from an electromagnetic point of view for military use, so hopefully they would survive okay in our rather noisy RF environment and EVs. So that's about it really. I really think this approach has got quite a lot to be said for it. I'd love to see something like this being adopted pretty well as normal procedure when people are converting EVs, particularly if they're using the lithium batteries. And it might even be that the OEMs could take a leaf out of this book if they haven't done so already.